네, 여러분 잠시 후 H2 미트 컨퍼런스 2023 테크 토크가 시작될 예정이오니 원활한 행사의 진행을 위해 소지하고 계신 휴대전화는 전원을 꺼주시거나 진동 모드로 전환해 주시면 대단히 감사하겠습니다. 아울러 본 행사는 동시 통역이 제공됩니다. 통역이 필요하신 분께서는 통역 수신기의 채널을 한국어는 1번, 영어는 2번으로 설정하여 이용해 주시기 바랍니다. 네, 여러분 즐거운 점심 식사 시간 보내셨나요? 네, 저와 함께 토픽 2에서 참여하신 분들도 보이시고 또 새롭게 참여하신 분들도 보이시는데요. 네, 이번 시간도 유익한 시간 되시기를 바라겠습니다. 네, 그럼 다시 한번 인사드리겠습니다. 안녕하십니까? 저는 오늘 행사의 사회를 맡은 아나운서 김지영입니다. 반갑습니다. 네, 그럼 지금부터 퓨일셀을 주제로 H2 미트 컨퍼런스 2023 테크토크의 토픽 3 강연을 시작하도록 하겠습니다. 본 세션은 총 5개의 강연으로 준비가 되어 있는데요. 각각 20분씩 진행이 되며 각 강연 끝에 질의응답 시간을 갖도록 하겠습니다. 네, 테크토크 토픽 3는 2시 20분에 마무리될 예정입니다. 끝까지 함께 하셔서 즐거운 시간 보내시길 바라겠습니다. 네, 그럼 먼저 국제수소에너지협회의 연구원 겸 그린수소 홍보대사이신 미카 Blugeon-Mered 님께서 Fuel Industries, Geopolitics, New Dynamics, Policies, Narratives 제목의 강연을 준비해 주셨습니다. 네, 그럼 무대로 모시겠습니다. Mr. Mered, please come up to the stage. 여러분 큰 박수로 환영해 주시기 바랍니다.
안녕하세요. 제 이름은 미카입니다. 초대해 주셔서 감사합니다. Thank you so much for your invitation. I'm sorry, I learned Japanese as my first language in school, not Korean, because at the time I was not a blink. Now I am, and I regret. But anyway, maybe I will be able to also pick up Korean. In the meantime, speaking in English. Is everybody speaking good English? Maybe not, just to understand if I have to speak very slow. Yeah, I will speak very slow. It seems like the translators will like that. So I have 20 minutes and approximately 40 slides to try to take you on a journey in the fuel cells industry geopolitics. The idea here is maybe not to cover everything. The idea, because you will have the slides anyway in the leaflets that have been circulated. The idea is really to share with you the main messages or the main results of my research. And let's start right away with the starting point, actually. So when we look at fuel cells from a business point of view, well, it's business. There's a bit of climate issues involved, but it's primarily business. When my father started in fuel cells 25 years ago, it's a family business. Then basically it was really research for the sake of research, and that's it. And then business. And now it's this. What you're seeing here is a graph showing you that the summer we've just had all around the world, the month of July 2023, is the hottest ever recorded on Earth. So of course, this is the kind of data that creates the hype, the urgency from a policy point of view that gets governments, companies, financiers, investors, regulators, and so on to develop this hydrogen fuel cell kind of industry. Then, now let's go down and deep dive. What you see here is what we should do, what we have to do, in fact, if we want to get to net zero by 2050. So what you see here is that basically in 2019, there was 1 year where basically we were on the right track for net zero. That was 2020 with COVID, where the world emitted 5% CO2 less globally than the year before, and then right after in 2021, 2022, and now 2023, we just got back up. to get there, the window basically is shrinking. And when I'm saying the window is shrinking, that should get policy makers and other people I've just mentioned before invest even more in hydrogen, fuel cells, and so on. But of course, it's more complicated than that. First of all, the numbers are so huge, that some people on the one hand will see this as a massive historical business opportunity. Other people will basically experience some kind of a disconnect between the reality and those numbers. The fact that those numbers are so huge will create a sense of defeat before even trying to understand better those numbers. It's too hard, it's too complicated, the mountain is too high, we will never get it. And basically, when you see the amount of electricity we will need to produce, the amount of electrolysis we will need to produce, the amount of green hydrogen we will need to deliver on a net zero strategy by 2050 with hydrogen, well, basically here, if you're in the first camp of the business opportunity, good for you. If you're in the second camp, it's really, really, really hard to actually get on your horse and get something done, because really that numbers are intimidating. So, after the Paris Agreement in 2015, we didn't have that wealth of research on hydrogen. We didn't have those super huge figures that were intimidating. And what many policymakers in Europe, in the US, in Canada, but also in Northeast Asia, what they did is they tried to basically see if there was something that could be done by leveraging hydrogen to deliver on the objectives of the Paris Agreement, but without being intimidated by some big numbers that we did not have at the time. And basically, that's how the first movement of public subsidies, regulation, facilitation, and many other types of mechanisms have emerged in 2016, 2017, 2018. That is when Australia built its first hydrogen strategy. That is when France built its first hydrogen plan. That is when, of course, Korea published its first version of the first hydrogen strategy back in 2018. So here is what you've got. What policymakers, regulators, administrations, and so on were focusing on at the time was something that was tangible, so that people could feel the policies that were being put in place, so that there could be some kind of a popular movement. And with this thing that is tangible, that people can see, touch, feel, that is in their daily lives, basically it would get something going, some ball rolling. And that one tangible thing that the 15 countries at the time that passed a hydrogen strategy or support mechanism or support a plan or whatever, they all focused on the one thing that it was the most tangible for the average consumer: cars, passenger cars. They didn't care really that much about trucks. As you can see, only 5 countries out of 15 had a component of their strategy focusing on facilitating hydrogen trucks. They didn't really care about the industry. Only 2 countries. And we're talking here about incentives without targets. Only 2 countries out of 15. Because, well, industry is not sexy. Even though it's the most efficient way to deliver this snowball rolling in favor of this climate action, even though we know the numbers that the industry emits in terms of CO2 and how this must be the first thing we need to tackle, the hardest to abate industries, we need to tackle them to get that ball rolling. Well, that was not the choice. Only 2 countries put an emphasis on industry at the time. Not tangible enough, not close to the consumer, or rather to the average voter enough in many of our countries, especially in Europe and in the US. So passenger cars. Okay, why not? And so people were like, okay, what are we going to do with passenger cars with hydrogen? At the time, you only had one big type of technology available, fuel cells. So, okay, let's go for fuel cells. Let's focus all our efforts on passenger cars and refueling stations and buses with fuel cells. Because, well, in the general media, in politicians and so on, administrations, well, it's fuel cells, it's easy, right? Fuel cells, you just take some hydrogen here, you just take some oxygen, you mix the two together, and boom, you've got some water and with some electricity, and voila, magic. And of course, you don't have to go further to develop a powerful message for a general public. It doesn't have to be deeper than that. Only, well, it's not that easy. And I'm sure in this room we have many engineers and scientists who know it's not that easy. And that is precisely the reason why, well, it was a weird choice. We explain it now in hindsight, right? But at the time, people thought it was good. You know, people will take hydrogen cars, hydrogen taxis, they will be convinced, they will see it doesn't make any noise, that it's drivable, etc., etc. Well, today, apart from Korea, China, and Japan, there's no really any country in the world where fuel cell electric vehicles have taken off. If we can say that even in Korea, China, and Japan, it has taken off. I wouldn't go that far, to be honest. But voila, that's what we've got here. We've got strategies in most of these countries focusing on a technology that was thought to be easy, but proved to be more complicated to implement in a wild scale that was believed, and that is actually way too small to kickstart an industry. Basically, the demand for hydrogen for transport applications in 2021, it was merely 0.03% of the global hydrogen demand. So you will never kickstart an industry, and more importantly, in the context of urgent climate urgency, with that kind of thing. If you were to focus on transportation and decarbonize transportation with hydrogen, actually the one way to get the ball rolling would have been to focus on shipping. And there's one country in the world that actually saw this coming and decided to include the decarbonization of shipping propulsion in its strategy. And that country was Korea. So definitely here, things are a bit different than in Europe. But that's the thing, at the end of the day, so we're now in 2023, in hindsight, too little distribution infrastructure, too little adoption, too much complications, and so on. And now the narratives around fuel cells are changing even faster. What is happening in fuel cells? So what you're seeing here is, once again, the stock of fuel cell vehicles we have in the world. So as you see, as of June 2022, we barely had 60,000 hydrogen cars, buses, and commercial vehicles in the world. As you see on the right-hand side, the one country in the world that is fueling this movement is Korea, then US, then China and Japan. Okay, but once again, it's too little. And not only is it too little, but there's one big actor that managed in just a matter of a few years to actually clinch the majority of the market. And that huge actor that only the US can certainly compete with is, of course, China. So if you ask any European car maker, any European car market analyst, they will tell you, well, fuel cells might be actually a bad idea, not just because it's ineffective in getting that hydrogen industry rolling, but because building fuel cells in a car is actually quite close to building an electric battery car. Who's leading in battery electric vehicles today? China. Can Europeans compete with China on battery electric vehicles? The answer is no. That's why in Europe we're taking a lot, the hardest, certainly the hardest protective measures vis-à-vis our own market to protect our car makers who cannot compete with China on costs and now even on technology. So then, from a European point of view, and even from an American one as well, what's the natural play once you realize that you can't compete? Well, you're going to change the game, or at least change the rules of the game. And that's where basically now you will get people saying in Europe, in the US, in Canada, well, we're going to have battery electric vehicles. That's a given. This ship has sailed. And then we've got the hydrogen thing for all these uses, transportation uses that can't be electrified directly with the battery. What are you going to do with that? Well, instead of building an FCEV, which China is basically already leading, and if it's not China, it's Korea, so it's not us Europeans or Americans, then basically we need to find another type of powertrain to actually keep our edge and protect our market and our knowledge. And that's how we have now a lot of debate in Europe vis-à-vis the fact that we should ditch fuel cells and actually promote internal combustion engines running on hydrogen. This narrative has changed. The switch happened in the past year and a half, and it happened very fast. And in Europe, it was even exacerbated when the European Parliament this year in 2023 decided to ban the sale of thermal cars in 2035. Because car makers in Europe were like, okay, so we have green parties coalescing all across Europe so that in the European Parliament, they passed this ban on selling new thermal cars by 2035. What's the alternative? Batteries, we're screwed. FCEVs, we're about to be screwed. What's left? Oh, ICEs. But ICEs, it's a thermal car. Yeah, it's a thermal car, but it's not running on fossil fuels. So maybe that's fine. Actually, that's the only loophole in the law. So definitely, this is just an example in the passenger car, lightweight vehicle. But then, of course, this message saying that fuel cells might not be the way, might be too complicated, might be actually a strategic vulnerability for Europe and the US, has basically spread to other parts of the hydrogen industry and these industries that could be abated with hydrogen. And when you look at the 5 main types of usage for hydrogen in a Paris Agreement context, what you realize is that actually fuel cells are not needed in most cases. So that once again pushes the narrative that we should ditch the fuel cell strategy and focus on co-firing, ammonia, internal combustion engines, and so on. So here, this is purely, as you can see, political. And I would dare say geopolitical. So refineries, fertilizers, steel making, we don't need fuel cells. So if that's what Sweden is focusing on, the Netherlands is focusing on, Germany is focusing on, France, Spain, etc., then basically fuel cells, okay, they're there, but we're not going to use them that much. So we can't build our new strategies, our 2023, 2024, 2025's updated hydrogen strategies on fuel cells. We can't do that anymore. So, talking about strategies, and I'm already at 15 minutes here, so it's almost the end of my presentation, don't worry. What you see here is the world of hydrogen strategies, national hydrogen strategies, back in 2019. So basically at this time where fuel cells were still quite popular. And Here in light blue, you've got countries who were just developing their hydrogen strategy, and in green, you had countries that already had a hydrogen strategy. So as you can see here, only 10 countries as of 2019 had a hydrogen strategy, Korea being, of course, one of them. Now, I'm going to show you the new world. The new world as of September the 1st, 2023. Please watch. The world has changed. We now have 59 countries with a hydrogen strategy. We have an additional 36, the ones in light blue, 36 countries developing currently their first hydrogen strategy. So basically, we're talking here about almost 101 actually, 101 countries participating to this institutionalization, this politically infused strategization of hydrogen. And what you realize when you pay attention to very close to these strategies that were published, well, fuel cells are going to be found only in the strategies of countries that are leaning towards China in terms of international business and international direct investments. So once again here, there's a divide that's very interesting. That's the figures for you. So 19 minutes, I'm reaching the end of my presentation. I only have 20 minutes. And of course, you understood that we did not cover the 40-ish slides. So here are the segments in the hydrogen business where one could actually find an interest in resorting to fuel cells. Maybe it's not a lot. Maybe it's not enough to reach net zero by 2050, to create the snowball effect we're talking about, and so on and so forth. Maybe it's not enough. But if you're looking at it from a business point of view, or if you're looking at it from a research, energy efficiency and so on point of view, then that's plenty enough for you to make a living. But now, my main message and my main question for you guys, everyone here in this room, ladies and gentlemen, is when you think about hydrogen, and when you think about the change that we need to deliver by 2050, which is in less than 10,000 days, should we have a global effort at the macro level on what matters the most? Or should we just think about business? Thank you so much for listening to me.
Thank you very much for your presentation. Thanks to you. Now fuel cell doesn't sound that difficult. 네, 감사합니다. So now we'd like to have Q&A session. So let's see if anyone want to ask you any questions. 네, 질의응답 시간을 잠시만 갖도록 하겠습니다. 혹시 질문이 있으신 분께서는 자리에서 손을 들어주시면 마이크를 전달해 드리도록 하겠습니다. 네. 질문이 없으시면 그럼 다음 강연으로 진행하도록 하겠습니다. 네, 다음 강연 소개해드리겠습니다. 포항 테크노파크의 디렉터이신 신경종 님께서 하이드로젠 퓨얼 셀 파워 제너레이션 클러스터 컨스트럭션 프로젝트라는 제목으로 강연을 준비해 주셨습니다. 여러분 따뜻한 환영의 박수 부탁드립니다.
네, 안녕하십니까. 저는 포항 테크노파크 그린에너지 센터 신경종 센터장입니다. 제가 오늘 말씀드릴 내용은 지난 7월 달에 우리나라 처음으로 수소 관련 예비 타당성 사업으로 선정된 경상북도 수소연료전지 발전 클러스터 구축 사업에 대해서 설명드리도록 하겠습니다. 먼저 클러스터 사업은 산업부와 경상북도 포항시 포항 테크노파크가 함께 공동으로 운영을 하고 있습니다. 먼저 수소연료전지 발전 클러스터에 대한 사업 개요입니다. 수소연료전지 발전 클러스터는 수소연료전지 국산화를 통한 세계시장 선도, 서플라이 체인 구축을 통한 연료전지 산업 활성화, 기업 유치를 통한 국내 기업 육성 및 신규 일자리 창출이라는 목표를 가지고 저희는 지금 추진하고 있습니다. 사업 기간은 2024년부터 2028년까지 5년간이며 총 사업비는 1918억 원이 되겠습니다. 클러스터가 조성될 위치는 포항시에 있는 블루밸리 국가산업단지가 되겠습니다. 이번 사업은 우리나라의 수소경제 모태가 되는 수소경제 활성화 로드맵을 기본으로 하고 수소경제 표준화 전략 로드맵, 한국판 뉴딜 종합계획 2050 탄소중립 추진 전략을 근거로 해서 시행을 하게 되었습니다. 방금 말씀드린 수소경제 활성화 로드맵은 지난 2019년에 발표가 되었으며 수소차와 수소연료전지를 중심으로 세계 최고 수준의 수소경제 국가 도약이라는 목표를 가지고 저희 나라가 추진하고 있습니다. 2040년까지 수소차 620만 대 보급, 발전용 연료전지 15기가와트, 가정 건물용 2.1기가와트 보급이라는 아주 적극적인 목표를 가지고 현재 추진 중에 있습니다. 그리고 이런 정책을 뒷받침하고자 수소경제 이행을 효과적이고 지속적으로 추진하기 위해 2020년에는 세계 최초로 수소경제 육성 및 수소 안전 관리에 관한 법률, 즉 우리가 쉽게 말씀드리는 수소법이 제정이 되었습니다. 여기에 발맞춰서 지방 정부들도 여러 가지 정책과 조례를 지금 제정하고 있습니다. 특히 경상북도와 포항시에서는 동해안 에너지 클러스터 조성 실천 전략 수립, 지역 에너지 계획 및 신재생 에너지 마스터 플랜 계획 수립, 포항시 신재생 에너지 종합 계획 수립 등 여러 가지 정책을 지금 수립하고 있습니다. 경상북도와 포항시에는 지방 조례를 제정해서 수소 사업을 추진하는 데 있어서 최대한 지원을 하고 있으며 수소 관련 기업들에게 인센티브를 제공할 수 있는 여러 가지 조례도 현재 만들고 있습니다. 다음은 클러스터 사업의 추진 배경에 대해 말씀드리도록 하겠습니다. 다들 아시다시피 연료전지 산업은 원료하고 소재, 부품에서 최종 발전 시스템까지 다단계 밸류체인으로 구성된 기술 집약적인 산업이 되겠습니다. 이런 연료전지 산업에 있어서 우리나라는 기술은 세계 최고의 수준으로 자부하고 있지만 산업화 기반 시설이 부족해서 연료전지 산업 생태계 육성이 아직 저조한 수준입니다. 우리나라 연료전지 산업은 발전용과 수송용을 중심으로 현재 많이 상용화가 되어 있습니다. 발전용의 경우는 REC 지원으로 인해서 소폭으로 현재 증가세를 이루고 있습니다. 하지만 내부적으로 제가 자세히 들여다보게 되면 스택이나 계질기 이런 핵심 부품들은 아직까지 해외 기술의 의존도가 상당히 높은 수준입니다. 그래서 이런 기술의 한계를 극복하고 여러 가지 기술의 국산화를 앞당기기 위해서 저희 사업이 추진되게 되었습니다. 그렇다면 왜 이 사업이 포항에서 최적지로 평가를 받아서 추진하게 되었는지에 대해서 설명을 잠깐 드리도록 하겠습니다. 포항은 이미 10여 년 전부터 해서 연료전지 테스트베드 구축 사업을 통해서 우리나라 연료전지 산업을 실제로 이끌어 왔습니다. 경상북도에는 연료전지 관련 기업이 약 105개가 위치하고 있고 그 중에 55개가 포항시에 현재 위치하고 있습니다. 그리고 저희 테크노파크에 있는 수소연료전지 인증센터하고 리스트에는 수소연료전지 관련 장비가 100종 이상이 이미 구축이 완료되어 있습니다. 그리고 저희 지역에는 포스텍이라든지 리스트, 포항 테크노파크, 포미아 등 여러 대학과 연구기관에 수소연료전지 관련 연구원 인력이 700명 이상이 현재도 연구를 진행을 하고 있습니다. 그리고 포항시에 지곡밸리라는 곳이 있는데 이곳에는 포스텍과 리스트, 가속기 연구소, IBS, 포미아, 막스플랑크 연구소 등 국내외 연구기관이 집적화되어 있습니다. 그리고 세계 최고 기업인 포스코가 위치하고 있어 수소연료전지 산업 시너지 효과가 상당히 높을 것이라고 저희는 평가를 받고 있습니다. 그러면 수소연료전지 발전 클러스터 사업에 대해서 간단히 설명을 드리도록 하겠습니다. 클러스터는 총 3가지 코어를 중심으로 저희가 추진을 할 계획입니다. 연료전지 관련 기업과 기관이 위치해서 산업 생태계를 구축하는 기업 집적화 코어, 그리고 연료전지 핵심 부품과 시스템을 평가하는 장비 20종 26기를 구축하는 부품 소재 성능 평가 코어, 그리고 여기에서 개발된 기술과 제품을 실증할 수 있는 국산화 시범 코어, 이렇게 3가지 코어를 중심으로 저희가 추진할 예정입니다. 클러스는 수소연료전지 서플라이 체인 구성, 기술 검토, 플랫폼 조성, 수소연료전지 국산화 선도라는 3가지의 큰 목표를 가지고 5년 동안 2단계로 나눠서 저희가 추진할 예정입니다. 먼저 1에서 3차년도인 1단계에서는 기업 유치, 평가 장비 구축, 인력 양성을 위한 프로그램 구축을 통해서 클러스터의 기반을 구축하고 4, 5차년도인 2단계에서는 기업 집적화를 완료하고 기업 지원을 위한 플랫폼을 구축하고 연료전지 ONM 기술을 고도화하기 위해서 클러스터를 활성화할 예정입니다. 세 가지 코어에 대해서 세부적으로 좀 말씀드리도록 하겠습니다. 먼저 클러스터 중에서 가장 큰 면적을 차지하고 있는 기업 집적화 코어입니다. 여기는 클러스터가 저희가 총 28만 제곱미터인데 기업 집적화 코어는 약 20만 제곱미터로 클러스터 중에서 가장 큰 면적을 차지하고 있습니다. 연료전지 관련 기업과 기관이 입주할 수 있는 공간으로 저희가 구성을 할 예정입니다. 그리고 전기나 가스, 설비 등 시설에 필요한 기반 시설까지 저희가 지원을 할 예정에 있습니다. 그리고 여기에 입주하시는 기업들에게는 경상북도와 포항시에서 제공해 드릴 수 있는 최대한의 인센티브를 저희가 제공할 예정입니다. 그리고 부품과 시스템 모든 분야에서 검인증과 평가를 할 수 있는 장비가 구축되는 부품 소재 성능평가 코어입니다. 여기에는 20종 26개의 장비가 구축될 예정이고 기업들의 연구소를 설립할 수 있는 공간과 창업, 벤처 기업들이 입주할 수 있는 공간도 저희가 건립을 할 예정입니다. 이번 코어에서 구축될 예정된 장비 내역입니다. 100kg까지 검인증 평가가 가능한 팸이라든지 SO 장비는 이미 저희 테크노파크 인증센터에 구축이 되어 있어 현재 보시는 표에는 그 펜과 SO 장비는 보이지 않으실 겁니다. 그리고 대부분 보시면 100kg 이상의 대용량 평가 장비들로 저희가 구축을 할 예정입니다. 그런데 한 가지 말씀드리고 싶은 부분은 이 장비들이 아직 확정된 건 아닙니다. 저희가 앞으로 입주하는 기업이라든지 기관과 협의를 통해서 변동이 가능하다는 점 저희가 말씀드릴 수 있습니다. 저희 클러스터는 기업이 필요한 장비를 구축하고 지원하는 것이 최대의 목적이기 때문에 언제든지 저희는 기업과 기관의 의견을 수렴할 예정입니다. 다음은 개발된 기술과 제품을 실증할 수 있는 국산화 시범 코어가 되겠습니다. 이번 코어에서는 최대 4MW를 한 번에 운영이 가능할 수 있는 유틸리티를 저희가 구축할 예정입니다. 클러스터에 입주한 기업과 장비를 활용해서 개발된 기술을 여기에서 바로 검인증, 실증을 할 수 있도록 저희가 지원할 예정입니다. 콜라스나 KS 인증 기관으로 이미 수소연료진 인증센터가 지정이 되었는데 이 인증센터와 연계해서 기술의 개발, 실증, 검인증까지 한 번에 수행할 수 있는 그런 원스톱 서비스를 저희가 구축할 계획입니다. 그리고 한국수력원자력과 공동으로 수소연료전지 발전소의 ONM 국산화를 위해서 저희가 인력 양성과 홍보, 기술 개발을 추진할 예정입니다. 클러스터 소개는 이 정도에서 마무리 짓고 저희가 운영하고 있는 인증센터에 대해서 간단하게 조금 더 설명을 드리도록 하겠습니다. 수소연료전지 인증센터는 저희 포항 테크노파크에 위치하고 있습니다. 포스텍과 포항 테크노파크 포미아가 공동으로 2011년도 수행했던 대경권 연료전지 테스트베드 사업으로 구축된 54종의 장비를 기반으로 해서 2019년 12월에 인증센터가 개소를 하게 되었습니다. 이 인증센터를 통해서 2020년에는 수소 융복합 인력 양성 사업에 선정이 되어 현재 저희가 석박사급 인력 지원을 하고 있습니다. 그리고 인증센터가 개소가 되면서 저희는 경상북도와 포항시에서 운영비를 매년 6억 원을 지원을 받아서 현재 인증센터 운영을 하고 있습니다. 이런 지원을 통해서 2021년에는 콜라스 공인인증시험기관으로 저희가 지정을 받았고 지난달 8월에는 KS 인증 위탁기관으로 저희가 지정을 받았습니다. 이거는 국내에서 두 번째고 경상북도에서는 유일한 그런 인증기관입니다. 그리고 인증센터에는 검인증 기능도 있지만은 저희는 중요한 게 하나 되는데 실증 지원 기능이 있습니다. FCI라든지 STX 중공업의 수소연료전지 제품을 저희가 21년부터 현재까지 2년 이상 운영 지원을 통해서 지금 현재 실증 데이터를 확보하고 있습니다. 그리고 다음 달부터는 45kW SOFC 시스템이라든지 일체형 수소 생산 시스템 실증 운영을 들어갈 예정에 있습니다. 그리고 21년부터 올해까지 3년 동안 국비 80억 원을 포함해서 총 100억 원을 저희가 투입해서 인증센터의 장비를 현재 고도화 중에 있습니다. 이번 사업을 통해서 저희는 SOFC 1kg, 10kg, 25kg 평가 장비와 PMFC 100kg 평가 장비, 그리고 대용량 EBOP 평가 장비 등 총 32종의 장비를 추가적으로 구축을 했습니다. 아마 구축이 완료되는 올해 말에는 국내 최대의 장비가 구축되어 있는 인증센터가 될 것입니다. 현재 스택 평가라든지 계절기 평가, BOP 평가, 모의 환경 시험 등 총 44종의 최신 장비가 구축되어 있으니 관심 있는 기업이나 기관들에서는 저희들한테 언제든지 이 장비를 활용해 주시기 바랍니다. 네, 이상 발표를 마치도록 하겠습니다.
네, 감사합니다. 네, 앞으로 구축될 클러스터와 또 인증센터에 대해 자세히 소개해 주셨는데요. 네, 많은 기대가 됩니다. 그럼 참가자분께 질문 받아보도록 하겠습니다. 질문이 있으신 분께서는 손을 들어주시면 마이크를 전달해 드리겠습니다. 네, 너무 잘 설명해 주셔서 질문이 없나 봅니다. 네, 감사합니다. 자리로 돌아가 주시기 바랍니다. 네, 그럼 다음으로 Automatic-Systeme Dreher GmbH의 바이스 프레지던트이신 토마스 컨 님이 강연을 해 주시겠습니다. 네, 강연 제목은 Manufacturing Concept for the Production of Metallic Bipolar Plates입니다. 네, 여러분 박수로 맞이해 주시기 바랍니다.
자, 신사 성여 여러분 안녕하세요. 내 이름은 김시호입니다. And I'm sorry, due to my poor Korean, I also need to continue in English. I'm glad that we have the opportunity today to bring you a little bit in a world, in a very practical world, to show you how some of the components which we are all talking about are really manufactured in mass production. I hope that this is working. You can see, of course, downstairs, the practical application which I will show you is for a truck, which is running on the roads. The truck itself is driven by a fuel cell. You can see a lot of information here on this exhibition about this. We have some confidential agreement, that's why I have to use my own computer. And I'm still trying to get it running. So, and of course then, the fuel cell itself consists on a fuel cell stack. The stacks itself, they consist on a bipolar plate, which is welded together as an anode and cathode. And then at the end of the day, you have the bipolar plate itself. And this is a chart where you see the complete manufacturing process, starting from the raw material, which normally comes from a coil, then the forming operations, then the washing, then the welding, then we have the leakage test. And in our case, we are using a post-coating process. And then, of course, we have the assembly coming to the stack itself, and then at the end of the day of the fuel cell. But, as I said before, what I want to concentrate is, and I did not see that somebody is showing something like this here on this event, it's about the production of these bipolar plates. We are a medium-sized company, and we are working together with other companies specialized in the manufacturing of each individual, covering each individual process. So there are companies like von Arden, they are for the coating. There is the company Weil Technology, they are involved in the welding, and then the company Zeltwanger, they take care of the assembly of the fuel cell itself. We as Dreher, we are now the one, very short update about who we are. It's a 50-year-old company. We have just moved 3 years ago when Corona started into a new facility. And what you can see, we have about 200 employees in our company taking care of everything which is related to automation in press shops. I think what's important, of course, the facility has been built. We are talking all about sustainability. What is, I think, important to know, of course, our building has been made based under the latest regulations. And as you can see, we produce actually almost 90% of our electricity, which we need to manufacture our machines by ourselves. So, In principle, what we do by ourselves is we manufacture all equipment which is in a press shop, but around the press, which means we do make everything in front of a press, inside the press, and behind the press. These can be coil lines, these can be destackers, these can be transfer systems, feeders, and stacking devices. What we don't build is a press by ourselves. But being in this business for more than 50 years now, we do not only supply single equipment, we became more and more also into a turnkey supplier, which means, and that's one example for that, we also act as turnkey suppliers in the sheet metal forming industry, which means we buy presses and we integrate it then in a complete system. That's an example of a blanking line to cut blanks for a press shop, for a big OEM in Germany. And the pictures, of course, we have not only as a drawing, but it's also in reality. The line is in production since 2 years and has been built under all bad circumstances during the Corona period. Those lines are used in the press shop to make blanks, which will be formed afterwards to components of the cars. In principle, our business is related about 80% to the automotive industry. And this, of course, for steel and aluminum. So, but coming now to the more important topic, having this experience now, not only as an automation supplier, it became deeper, as I said, into the complete forming systems, which includes not only the equipment, but also the development of components, which has to be formed afterwards, and we are working together with die manufacturers then supporting us in the manufacturing. And as I said before, what I would like to show you is the manufacturing process at the end of the day of a bipolar plate which is used right now for a truck. The challenge for us, I'm not sure who is out of the forming industry, but what I usually say, a lot of geniuses have good ideas, develop something new, but somebody at the end of the day has to manufacture it and has to find a possibility to make it happen. And for us, there is one important number. I mean, the bipolar plates are made out of stainless steel. That's not the challenge. The challenge is this number here. You see, the thickness of the blanks, which we are running in full production right now, is 75 microns. So if you use a paper, which this is similar. And then the challenge, of course, for us was how to feed material like this into a die, how to form it, what kind of force do you need, and how to handle the whole equipment without damaging something. Actually, this was not developed then from one night to the next. We have a customer and he trusted us, and we had the whole development started actually already 6 years ago. 6 years ago, by developing the process, you see on the left side, we make first the holes into the part. Then we form it. We have a kind of preforming operation. We have an embossing operation. And finally, we cut it. And maybe to your surprise, what I will give you now into your hand is the real parts. And then I think it's always better to feel a little bit, because then maybe you understand how quite complicated it is to handle part like this. I will give it through, you can touch it, I will give it to you. But of course I need to get it back afterwards. But please be careful, because the edges are very sharp and it is very easy that you cut your hands. So I want you, if somebody is hurting himself, I'm afraid it is your then. It's your task. So what you will see here is, this is the first operation where we cut it. We cut it in 2 stations. So first it comes from the coil, then we cut the holes because we need these holes for centering. Then this one is number 2. This is the embossing operation of the flow field as a preforming. And then we have position number 3. This is the final embossing operation to form the complete flow field and also the other areas. And then here, this is the final product, which comes out of the line, which I will show you afterwards. And I'm sorry, there are a lot of wrinkles, of course, at the in the production. Of course, these are scrap parts. You know, it is so sensitive. I tried to protect it in my luggage, but as you see, it was not really possible. So of course, the lines when the parts come out of the line, they are of course flat. As I said, nobody had any idea about how this material will work and how we can, you know, work with the material. That's why we have used at one of our customers a very old machine which was not designed for this. It's a hydraulic press. It's a 1,600 ton press, which was absolutely not designed, and we had to find a solution how to make the first tests. And what I would like to do is, I would like to ask you to start the first video. We have developed for this process then a die-mounted transfer system just to get the feeling how we can handle the material. What I show you now, the video, is after 2 years learning, understanding, learning how to feed the material, and the machine is still in use for pilot productions. So I think you have to push on the left picture, and then hopefully the video will start. Okay? So you see, this is real production. Yeah, no more theory, real production. On the left side, we feed the material. Then you see on the front side, you see our gripper system. And what was interesting for us is first to understand how can we feed the material. It took quite some time to develop each component because the material is really sensitive, and to understand how sensitive, take 2 meters of paper, try to feed it, try to push it, and then you will understand that it's not just, you know, using a feeder and push it somewhere. Can we maybe repeat it again? I'm talking too much and the video was too short. No, maybe one back. Sorry. Yes, please. Yeah, komm schon wieder. I need to help for one moment. Okay, no, it's working. Okay. And then what we also had to understand is the flow field is so sensitive, so it's not possible to use ejectors inside the die, which means after forming, it took some time to understand how we can get the parts out of the die without an ejector. And that's what you see. We clamp, now the die is closed, we clamp already the parts, we lift it, and we take it out with the transfer system. What's then interesting afterwards, I will show you this later on in the mass production line, to get the parts at the last station out of the die. This was also a big challenge because using vacuum units, the stroke of the machine would be too big, so it would be not possible to achieve the cycle time which was required. And using grippers, it's also not possible because then, in this case, we would damage the flow field and the parts itself. So this is what you have seen before, was the line for tryout and for development. And this is now a picture of the final line, which is in full production. It consists, of course, of a coil line, so we are running from the coil. We have since, let's say, the surface of the material is very, very sensitive, so we are using a brushing unit to clean the surface. We have a roller feeder, which is quite special. We have a lubrication unit because for forming the flow field, we need, of course, lubricant. Then we have a thin coil material guiding system, which is quite special. Then we are using a transfer. And at the end of the line, we are using a conveyor system, which I will show you afterwards. And of course, we are using a monster of press because we are running those parts which you have in your hand with a capacity of 1,280 tons just to form these parts. So you will see some of the components in reality. Left is the decoiler, the brushing unit, the roller feeder, and also in the roller feeder there are a lot of technical details which I could explain you the whole day, but it's not just a standard roller feeder because there also we have to be careful that there will be no dust or no hair or nothing on the rolls because this would damage the flow field immediately. So you see the guiding, you see the lubrication, and then you see the support rolls, but I think you see them better here on this picture on the left side, because normally when you feed material, it's just good enough that you have from time to time some rolls, but we recognized due to the very thin material, we have to find a possibility to have every time the material supported by one of these rolls. These are very light moving rolls, because also there we have an agreement with one of our suppliers, and it really took some time to understand these normal rolls. For normal rolls, the resistance would be too big, which would cause already wrinkles. So also this was interesting then to realize, because we thought taking some support rolls, will be easy, but it took a couple of weeks to find the right solution. Coming to the press, because the press is also a very important part of this. The press is built by the company Andritz Kaiser, which is a very big organization. Kaiser itself, it's a German company. It's located in Germany. Company with a similar size of what we have. They belong to Andritz since 2004, so quite big organization. But the specialty of Kaiser is in a field of special presses, which are very strong and very rigid. I see that time is running, so I will skip some of these charts. What is important to understand is the dimension of the product at the end is 400 by 140 millimeter. The material itself, it's in Europe, it's called 14404. I understand in Korea, it's a kind of 3 series, and the thickness is 0.075 millimeter. The 4 main operations you have seen in front of you, and what might be also interesting is to produce the flow field, which was required by the customer. We need about 2.5 tons per square centimeter to form it. So then what was the challenge for the press? You see, this is the distribution of the forces. So very low force for cutting, quite a big force for the embossing, for the pre-embossing, the final embossing. Then, of course, we need these 800 tons, and then the cutting at the end of the day, it's also quite a small force. The challenge for such a press then is, if you have the normal force distribution, there is a very big off-center, and then this is causing, of course, imparallelism of the machine, which has an influence then on the forming of the final part. That's why we had moved the structure of the press. I will tell you a few words about this, but we also moved the die into a position that we have the central force in the center of the machine in order to prevent any deflection of the machine. Another topic is normal presses. I'm not sure whether there is a press builder here, but normal presses, we try to have our pressure points as far as possible outside the center. In this case, we just made it the other way around. We had to put it into the center, because if not, we would create deflections of the components itself. So we also understood that the stiffness of the machine itself was quite important to realize the accuracies which were required by our customer. Another topic is, I call it monster machine, because on the left side on the picture you see this is the normal structure of a press. Everybody's doing this in this way. So you have 2 support brackets, but this is causing in between some deflection, which is of course not good to produce those parts. The standard design of Kaiser is already a little bit stronger, so they have 4 brackets, but we also recognized in all the tests which we made that it's still not stiff enough. And that's why we have a structure of 6 brackets also in the center of the machine to prevent any deflection. I will show you some real pictures of the machine. The machine itself, as I said, 1,600 tons. It's quite a huge machine. The weight of the machine is 280 tons, just the weight. And you see now some of these components. This is just the press bed. On the left side, you see the drawing. On the right side, you see the real components. The lower press crown, the upper press crown, and the slide, all these components, they are casted. And I think from the machine building point of view, that's the most important chart. You see, we have a stiffness of about 0.05 millimeter per meter at a force of 1,600 tons. This is less than 1/3 of the deflection of a normal press. And this only can be realized by changing the structure of the machine and using a complete casted frame. So, since time is really running, of course, I will show you still some real pictures. This shows the machine during the installation. And what I will do is, I will show you the videos, maybe the first one on the left side. This shows the line in full production. The one on the left, the small bottom on the left. At a speed of 38 strokes per minute, producing bipolar plates. And these plates which you have in your hand are produced on this machine. At the end of the line, since we cannot pick up the parts, we have a servo axis which is lifting the parts and which is taking it out of the press. We put it on a conveyor belt, and from there it goes then to a separation station and to a stacking station where it goes to the washing machine. The full production, this was still during the tryout, the full production was running under, is running today in 3 shifts on 2 lines, one for anode, one for cathode in parallel, and going then together in parallel through the washing machine and then also to the welding machines. The full production right now is stable, running at 40 SPM, and we are trying now to optimize together with the customer to achieve 45 SPM. So, I think we skip the next one. And what I usually say is, not everybody can make everything by himself. At the end of the day, we only can be successful if we are working together as a team. And there is something very important about the meaning of the word team. In German, there is a very strange saying. This means, great, another one will do it. Toll, ein anderer macht's. Yeah? But there is a Jean Todt, he used to be the president of Ferrari. He said one day, together, everybody achieves more. I like this meaning, and that's why we created this group to be able to supply then at the end complete fuel cells in this kind of cooperation. Thank you very much for your attention, and
Thank you very much for your presentation, and thank you for giving us a chance to touch and feel the real bipolar plates. It was so interesting to see real machines. And let's see if we have questions from the floor. 질문 있으신 분 계시면 손을 들어주시기 바랍니다. Oh, yes, we have questions.
Thank you very much. Just one quick question. For this kind of products, who is your main off-taker now? Are they local in Germany? Is it some companies part of the Mittelstand, or is it bigger groups? Is it foreigners? Just don't know, nothing confidential, I guess, but...
the name of the company, but it's the parts are produced in Germany. And if you have watched on the first picture, you know the end user.
Okay. Thank you for the hint.
Thank you very much. 네. 그럼 계속해서 다음 강연 청해 듣도록 하겠습니다. 다음은 Fuel Cell Cascading Challenges and Solutions를 주제로 Saint-Gobain Composite Solutions의 글로벌 비즈니스 개발 매니저이신 프랭크 손넨샤인 님이 강연을 진행해 주시겠습니다. 네, 그럼 연사분을 무대 위로 모셔보도록 하겠습니다. 네, 환영의 박수 부탁드립니다.
Good afternoon. I don't speak Korean at all, so we'll do it all in English. I hope that's okay for you. Thanks for setting the benchmark so high, so I just could fail. Thank you. Very short agenda. Introduce the topic of myself, because that's part of where the journey begins. Opportunity and urgency is the why, like why we are here, why we're doing what we want to do. And the mandate issue and the solution is, what are issues we're facing in doing what we want to do? And how can we overcome those issues? Then just summarize that, and then a bit of a conclusion and outlook, so what will be done next? Opportunity and urgency. I guess everyone has seen pictures like that before, but nevertheless, it is important for all of us to understand this is a global market trend. It's one of those mega trends that I truly believe everyone just sees once in his or her life. It's like internet, it's like mobile phone, it's like cars 100 years ago. I truly believe fuel cell, electrolyzer, hydrogen usage in general will change our way of living substantially. I truly believe that. I don't want to go into the numbers too deeply, but as you see, the little dot down there is where we are today. And even today, hydrogen is in everyone's mouth. Like hydrogen is in topic of every initiative from every country worldwide already today. And it's the little dot down there. Guess what happens with hydrogen in the next 10 years, in the next 5 years, in the next 25 years? That will change everything. I'm fully sure of that. And why is that? Sorry. My apologies. And why is that? Because we have more and more hydrogen-driven solutions. It starts with forklifts. The big aim is to have the cars running with hydrogen, full plants, metal production plants, sites, gypsum sites, everyone consuming hydrogen a lot has plans currently to transfer that to hydrogen-based energy. And with more energy hydrogen consumption, hydrogen production must follow. Like obviously, we only can use hydrogen that we have. So when the fuel cell demand rises, also the electrolyzer demand rises in order to produce the hydrogen we need. I personally am here for the company Saint-Gobain. I won't go into detail here. Saint-Gobain is a very old company, like more than 350 years old. We have got roughly 160,000 employees worldwide. We are a big company, but nevertheless, we are a very innovative company, and every fifth product we sell today has been developed over the last 5 years. And we understand that as one of the major trends for future. This is me. I'm coming from automotive transmissions, so totally different world. I worked for General Motors, for Ford. I worked for some tier 1 suppliers of that. So I've got a transmission background, but I'm standing here. We talk about hydrogen, and this is part of that journey I would like to invite you to follow. I'm a seals guy. Like, I did gaskets for the last 15 years maybe. Okay, we're coming closer. We talk about gaskets today. And today I'm Global Business Development Manager for hydrogen. So when I started, I didn't have any idea about hydrogen. Like, no clue, no idea. Never had any touching point. I'm no chemist. Like, I'm a quite good engineer, but no chemist, no energy technician, nothing, okay? So when I started, I had 1 million unknowns. This is the journey that I have been part of, that I walked through, and I heartily invite you to follow me on that journey. Because I truly believe that a lot of people don't know exactly what they're doing. And I've been one of those. Like, I've been responsible for it, but I didn't have any idea. So what I did is I browsed the internet, I looked up at, I don't know, 1 million YouTube videos. I walked shows like these to talk to people, to ask questions, to get answers, to understand what am I talking about, what am I supposed to know, like what answers should I be able to give in future. And what I found out is that it's not a mature market. It's not a mature business. Like, I worked for automotive, as I mentioned before. Like, the transmission today looks the same like the transmission 20 years ago. It has a gear more or a synchronizer more, but it's the same thing. But on hydrogen, on fuel cell, on electrolyzer, everything's new. We all start from a blank page. There's a lot of trial and error. And there's a lot of error in trial and error. So for every question I asked, I got 2 different answers. And every different answer raised 3 more questions. So I was totally confused. So I made a file in Excel and just note down my questions and the answers. So I had asked the guy, like, what's the standard thickness for gasket? And the guy said, it's very important that the gasket is maximum 100 micrometer thickness. Our aim is 50 micrometer. I said, okay, that's great. That's great. I asked another guy 2 weeks later for the same application, the same question. He said, it's very important. Minimum thickness of a gasket is 500 micrometer, better 750. So what? Like, it's the same question, two totally different answers. And this is why I'm here, because this is one part of the challenge. One part of the challenge is to understand the difference, to understand that the different designs, even different names, like the one calls it frame gasket, the other one calls it main gasket, the one calls it sub gasket. So it's not just gasket. It's a lot more than that to understand what do people talk about. Different tasks, like every gasket has got another function. The one gasket is for leakage prevention, the other gasket is for overcompression resistance, the other gasket is for electric conductivity blocking. Like, if you ask me, Frank, what's the best material for gasket? I don't know, because I don't know exactly what we're talking about. And to understand that, to accept that, to understand that we don't have all answers now. We need to ask more questions and then come to a better answer. And obviously, fuel cells and electrolyzers, for example, PEM and alkaline, they all have different tasks, different demands. It's a lot of text. I'll guide you through it. It starts with the application. Like, the application leads to the material. Like, for example, a low temperature PEM very often operates at, I don't know, 70 degrees Celsius. Very often, low temperature PEM can work with silicon-based gaskets or rubber-based gaskets, elastomer-based gaskets. If you talk about high temperature PEM or alkaline electrolyzer, those won't work. So the application, the better you understand the application, the better you understand what material you're talking about. Once you have the material you talk about, for example, plastic, PTV, or polyamide, whatever, then you talk about manufacturing process. The material defines how to produce. It's exactly as the speaker before said, like, it's kind of easy to have a genius idea, but if you don't find a way to produce it, cost efficient and mass production, the idea is dead immediately. So we need to find that. And obviously, an elastomeric gasket solution has a totally different process of manufacturing than a plastic gasket solution. And then the manufacturing itself, you can either mold in place, or you have rolled and rolled goods. You can use sheets. You can use materials on a roll. All has its pros and cons. But we need to follow that rule, okay? And then it's a lot of text. Please don't read it. I will guide you through it. I found out that depending on which part of project step my customer is in, the solution is a different one. Like, if you talk about startup companies, they're there to get subsidiary money, to get to build up something totally new, to start from blank page, to build the first demonstrator. They talk about 5 pieces, 10 pieces, 7 pieces, 20 pieces. So you have a lot in manufacturing, like really a person stacking something. You talk about very small stack sizes, like 3 pieces, 3 cells, 5 cells, maybe 1 cell design, just to demonstrate we can do what we're supposed to do, okay? And supplier, that is in that case us, maybe some of you, the demand of your customer is dictating your demand. So I follow my customer. If my customer is looking for, we're changing design often, it doesn't make sense to build a big tool costing several thousand euros. And the moment the tool is made, the design changed a bit. The bore is a bit left. The bore is a bit bigger or smaller. The diameter is a bit more or less. The radius changed it. So I have to change the tool again. It doesn't make sense. So the customer dictates kind of my approach to make those parts. And that's important to understand, because once that phase is gone, you have those small first orders, like you talk about 100 gaskets, 2,000 gaskets, so it's 10 stacks, it's 25 stacks a year. That's still important for the customer because obviously it's bringing them closer to the market, they learn with it. And for us, it's also important. So you have the first test stacks, you have the first customer feedback really on a stack level. And that means for us, okay, 2,000 gaskets is too much to cut out by hand. So you have first ideas about partially automated production, about packaging and handling. Like if you've got 2,000 parts that have to be produced at point A and have to be used at point B, you need to make thoughts about how to transport, how to package and stuff like that. So again, the customer process, the customer project dictates what we're doing. And then obviously is where we all want to be in the end. We talk about serial production. We talk about 20,000 gaskets, 100,000 gaskets, 1 million gaskets. Like we talk about run at rates. We talk about PPAPs. We talk about PSWs. We talk about all those funny things like quality control. Like at the first step, no one cares about quality. No one asks what dimension tolerance does the thickness have. Like it must work. They need parts. In the end, you talk about waste. You talk about supplier process control. You talk about how can I set up my process in a way that it supports the customer serial production process. You talk about warranty. Like at a startup, no one asks for warranty if the gasket doesn't work. Deliver gaskets to VW, 1 million pieces a year. You will have a very, very exact knowledge about warranty and prices and waste and stuff like that. Again, it's the same part for the same application, but a totally different approach from the supplier side in terms of what needs to be done when, depending on the customer status, the project customer status. That's the last slide now. It's just one example of how does the customer's serial process dictates and leads to our serial process. Like usually we do something like a die cut and that's it. We die cut the parts, we stamp them, die cutting, whatever the right word is, and then we stack them and pack them and send them. Okay. In that case, you have a lot of waste that either can be transported to the customer, and then the customer has the waste issue. They don't want that usually, or we have the waste, and we don't have control about the waste, and the customer has a box with whatever 100 gaskets in, and is trying to take those gaskets and feed to a system that is highly automated. So one example of our answer to that issue is the kiss cut process. What you take is the darker blue one, lower one, is a carrier film. And on that carrier film, it's slightly adhesive, slightly tacky, slightly adhesive. You bring the material to be cut, the gasket material, the PTFE, the polyamide, the whatever material of choice. And the cutting tool will cut the gasket material, but not cut the carrier film. So it all can be transported, so it all stays in line. The whole roll will be rolled up, will be sent to the customer, and it can be very, very clearly positioned because it is machine controlled. So there can be an automated take-off procedure at the customer to feed the stacking line. So in that case, it would reduce the customer process time. It is a more expensive process because you need the backing film, but the overall cost is significantly reduced because it can speed up 30, 40, 50% the customer serial production time and increase their output significantly. It's just one small example for customer process kind of dictates or leads to supplier process. So that's the summary and the outlook. So we learned that the design leads to the material, that material leads to the process, and there is a lot of differentiation, to comparison sometimes difficulty because of people using different names, people using different assumptions. There's a big difference between elastomer and silicone gasketing versus plastic gasketing, and there's a reason to use both. So it's not better or the worst product. It is the right or the wrong product, and it's our job to search it. And recycling and waste prevention gets more important the higher the number of output pieces is. That's it.
Thank you very much for your presentation. Oh, it was so impressive to see how you overcame the challenges and find solutions. And let's see if we have questions from the floor. 네, 질문이 있으신 분께서는 자리에서 손을 들어주시기 바랍니다. Sorry, maybe we don't have questions. So now please
Thank you so
return
much.
to your seat.
Thank
네,
you.
감사합니다. 큰 박수 부탁드립니다. 네, 이제 마지막 강연이 남아 있는데요. 마지막 강연으로는 호리바사 에너지 앤 인바이러먼트 디비전의 데퓨티 제너럴 매니저 하루히토 모리님의 강연이 있겠습니다. 여러분 큰 박수로 환영해 주시기 바랍니다.
Hello, everybody. I'm Haruhito Mori. I'm in charge of Energy and Environment Division, HORIBA. First of all, thank you very much for giving the chance to explain about our activities here. Thank you very much. The title of today's my presentation is HORIBA's Challenge and Contribution to Hydrogen World. Today's contents are together with an introduction of the activities of HORIBA, and it will also show the direction of strategy of hydrogen in Japan. At first, let me introduce a bit about HORIBA. HORIBA is a manufacturer of analytical and measurement systems based in Kyoto, Japan. It was founded in 1953 when our founder, Dr. HORIBA, developed Japan's first pH meter. So this year, 2023, marks our 70th anniversary. HORIBA started our business with pH meter and has expanded our business with analytical and measurement technology at our core technology. This slide shows an image of current HORIBA's various business domains: water quality management, global environment conservation, automotive, ship development, manufacturing process, agriculture, new material development, IT infrastructure, health and security, and also space development. As our business is largely B2B, business to business, expanding with various measurement technologies. Today, I would like to introduce our efforts in the energy and the environment field, especially hydrogen-related topics. Our products or services underpinned by our measurement technologies about gas measurement, fluid measurement, and solids measurement. The items highlighted in yellow are the energy and environment part involved in current our interests. One of HORIBA's characteristics is our global network. We have 50 group companies located around the world, and overseas sales account for 73% of our total sales. The HORIBA Group currently has net sales of approximately 270 billion Japanese yen and more than 8.4 thousand employees. In addition, the percentage of non-Japanese employees has risen to 64%, maintaining a well-balanced composition in Japan, Europe, Americas, and Asia, in terms of both business and human resources. As I explained, HORIBA works in major regions of the world and contributing to carbon neutrality, which is accelerating in many regions of the world, starting with Europe, that has invested in renewable energy and hydrogen over the last few years. To achieve the carbon neutrality, following these 3 steps are important: maximize total energy efficiency, utilize sustainable green energy, realize carbon capture and circulation. HORIBA will contribute these activities with our analyzing and measurement technology. This is also our mission to achieve carbon neutrality. The transition from existing fuels such as fossil energy to clean fuels like hydrogen and ammonia, which do not emit CO2. Over the past few years, HORIBA has been actively investing in the energy and environment field. We have not only expanded in Japan, but have also proactively established factories and development centers in Germany, China, and the United States. This has positioned us with a big advantage, as it allows us to quickly access global development trends and propose the necessary products at the right time. In the process of production, storage, and consumption of energy, HORIBA offers a range of solutions through efficiency and labor savings of the power plants to evaluation and analysis of fuel cells. Regarding carbon neutrality and hydrogen utilization, I would like to inform two investments, for instance. Left-hand side shows HORIBA E-Hub. This is our new facility in Germany, with an expectation to contribute to future business growth as a global hub base for the HORIBA Group's new energy business. HORIBA acquired Fuelcon, based in northern Germany, in 2018. HORIBA Fuelcon specializes in the development, production, and sales of evaluation equipment for fuel cells, electrolyzer, and battery. We have delivered numerous test stations to market-leading companies worldwide. We immediately decided to construct a new factory where we manufacture fuel cell test equipment and water electrolysis cell stack performance evaluation equipment in the year following acquisition Fuelcon. This was the best timing, since demand related to hydrogen energy has recently increasing sharply. We will respond to these demands by strongly enhancing productivity for 3 times the previous factory. Right-hand side shows our other facility in Leichlingen, Germany. Also have begun its operation of the facility with expansion of environment capabilities for 2 times, where we manufacture gas analyzers. We will contribute measurement needs towards the realization of carbon neutral society by providing total solution that is combined with multiple technologies into gas analysis and evaluation of fuel cells and hydrogen production. This is our lineup of electrochemical evaluation equipment for electric generation by fuel cell and hydrogen production by electrolyzers. In the upper section, we have products used for automotive PEM-FC, while in the lower section, we cover products used for stationary power generation SOFCs. Our range of evaluation equipment includes MEA, cells, stacks, and systems covering from research and development application to line and quality check of mass production as well. To achieve wider adoption to the market of fuel cell vehicle and systems, it's essential to enhance the performance of fuel cell systems while reducing costs. It needs a broad range of evaluations. Furthermore, since the characteristics required by fuel cell vary depending on their applications, it's essential to analyze, measure, and evaluate fuel cell under various conditions. HORIBA provides comprehensive solutions ranging from the analysis of constituent materials and substances to fuel cell system assessments. Through our solutions, we aim to improve the performance, reliability, and durability of fuel cells, contributing to the realization of fuel cell mobility for the broader market, including commercial vehicles like trucks and buses. This protocol is also applied to electrolyzer testing. As I show you on the previous slide, our products contribute from material level R&D to system level validation. On top of that, we can offer testing service, engineering, and consultancy services. By covering all processes consistently, data from downstream process can be feedback to upstream, making it easier to implement the plan to check action process cycle through HORIBA platform. Next, let's look at the global market situation. I won't go through what is written here one by one, but the hydrogen strategies of various countries are keep evolving. With recent development being the European Green Deal Industrial Strategy and the US Infrastructure Reduction Act. In the past, the aim of hydrogen installation to the energy market was to exchange the energy between region and energy circulation. But nowadays, the aim is establish an intra-region closed circular economy within their respective region by closing the value chain from a political perspective. As a result, we can see a competition to dominate in the hydrogen business and technology is occurring between Europe and the United States, I think. From here, I would like to talk about the situation in Japan. This slide shows the path to carbon neutrality by 2050 by the Ministry of Economy, Trade and Industry. The approach is 3 steps. The first is to reduce the use of fossil fuels as much as possible. In other words, through energy savings and efficient use of energy. The second is to change the energy use to carbon-free renewable energy, efficiently converting natural energy such as solar and wind power into secondary energy and using it in the right place without generating losses. Third, if fossil energy must be used, the carbon dioxide emitted should be properly captured and storage or utilization. I would like to explain about Japan's basic hydrogen strategy briefly, which was published by Agency for Natural Resources and Energy. The original hydrogen strategy was formulated with the aim of effectively developing hydrogen technology and creating a domestic hydrogen market ahead of the rest of the world. Compared to other countries where potential needs for hydrogen are expanding with the introduction of renewable energy, the expansion of hydrogen market with renewable energy is still unknown in Japan because the limitation of renewable energy. Hydrogen investment and tax credit are implemented in various countries. Japan aims to take advantage of its technological strengths to pursue a world where Japan's core hydrogen technologies are utilized in the various hydrogen businesses. That's the current situation and my understanding. This graph here shows the type of technology development that Japanese government's Green Innovation Fund is investing in. The largest funding is for development of hydrogen shipping, including transport technologies, for example, liquefied hydrogen, compressed hydrogen, ammonified methyl cyclohexanes, and others. As I mentioned before, Japan, which is poor in renewable energy, has to import green hydrogen from abroad. Various methods of hydrogen transport are being developed in parallel in terms of energy density, ease of process, and cost. The second largest investment is in the development of hydrogen-reduced iron-making technology. The iron and steel company, which emits high level of CO2 in the process, is attracting attention as an industry in need of improvement. The next is develop carbon recycling technologies. Finally, I would like to summarize Japan's direction with regard to hydrogen. Until now, Japan has proceeded the development of fuel cell technologies through FCEV and hydrogen refueling station and household fuel cell cogeneration system we call NFARM in Japan. Hydrogen has recently come into the spotlight as energy carrier for maximizing the use of renewable energy. Japan has to import a lot of energy, including hydrogen utilized fuel. The government has decided to update the strategy to not only develop the domestic market, but also expand Japanese technology into overseas markets in order to achieve carbon neutrality by 2050. In addition, this is a changing point from the previous strategy. Japan decided to add the basic hydrogen strategy also covers ammonia, e-methane, and synthetic fuels, e-fuels, to promote carbon neutrality. Yeah, this is a conclusion my presentation. Thank you very much for your kind attention. Thank you.
Thank you very much for your presentation and congratulations on your 70th anniversary.
Thank you very much.
Yes. And let's see if we have any questions
Yeah.
from the floor. 네, 혹시 질문이 있으신 분께서는 손을 들어주시면 마이크를 전달해 드리겠습니다. 네. Maybe we don't have questions. Now please return to your seat.
Thank you very much. So we have a booth in the exhibition hall. So if you have some question, please ask for HORIBA's guys. Thank you very much.
네, 감사합니다. 여러분 다시 한번 큰 박수 부탁드립니다. 네, 여러분 유익한 시간 되셨나요? 그럼 이상으로 테크토크의 토픽 3 Fuel Cell 세션을 마치겠습니다. 내일은 Storage and Distribution이라는 주제로 토픽 4가 이 장소에서 진행될 예정입니다. 참가자 여러분들의 많은 관심과 참여 부탁드립니다. 네, 지금까지 사회자 김지영이었습니다. 감사합니다.